At the point when we distinguish structures in the depths of space that shouldn't actually exist on paper, who is off base? The universe or our hypotheses? For a considerable length of time now, the James Webb Telescope has been utilizing its infrared vision to investigate the most far-off and most seasoned structures in the universe. It has over and over shown us that the real outgrowths of the universe are not especially inspired by our models, and that their simple presence plunges established cosmology into turmoil. For example, specialists still can't make sense of how, only 200 or 300 million years after the Big Bang, there could already have been galaxies as large and massive as our Milky Way today. But this is by no means the only mystery that Webb has now added to the star guides. It has also shown us the surprising blooms that the planetary universe of the cosmos can create. Some things basically have a place together constantly, like a planet and its host star. This is hardly surprising, since all planetary worlds in our home system orbit the powerful Sun. And if we look past the galactic horizon, we recognize that exoplanets are basically identified by the way that they orbit a star other than the Sun. But did you know that there are also planets out there that break this major design, and instead make their journey through space without stellar help? These introvert stars are known as maverick planets, and we are dealing here with either celestial bodies that were catapulted from their original system after their formation, or those that were never gravitationally bound to a star in the first place. The latter are also known in expert circles as sub-brown dwarfs. Furthermore, their birth didn't occur as normal in a protoplanetary disk, but also with stars or brown dwarfs, through the contraction of a stellar gas cloud. Anyway, it's in the nature of things that such planetary recluses are relatively hard to detect in the vastness of space. After all, they do not focus visible light and barely reflect starlight by any stretch of the imagination. But with the help of infrared telescopes, it's possible to identify rogue planets, or candidates for them, based on their own heat emission. In fact, our past examination of our cosmic neighborhood has shown us that rogue planets are by no means as rare as one might expect. In actuality, they are plentiful in our home galaxy. Specifically, astronomers now estimate that there are 2 times as many maverick planets as stars in the Milky Way. As such, if our galaxy is home to an estimated 100 to 300 billion stars, it also has around 400 billion free-floating planets. And as we now know, there is one specific region that is home to an especially large number of rogue planets: the Orion Cloud. What Webb has found in the Orion Cloud? In cosmic terms, the Orion Cloud is practically on our doorstep. Since the large cloud of interstellar gas is not only barely 1,350 light-years from us, but also one of the most dynamic star nurseries in our cosmic neighborhood, it has become a popular object of study for decades. Many years of research have estimated that around 2,800 young stars are dormant inside the Orion Cloud, and the immediate area is also adorned with countless shining celestial bodies. However, to literally focus another light on the notable, the James Webb Telescope pointed its near-infrared camera near camp at the Heavenly Nursery a couple months ago and captured 2 wide-angle mosaics of the Orion Cloud. These consist of more than 3,000 individual pictures, and they have revealed something that does not fit into the galactic picture at all. To be specific, in all honesty, 40 free-flying planets in one singular motion, which, as previously mentioned, come without a mother star. Despite the fact that rogue planets have been found in the Orion Cloud in the past, these delegates are especially massive celestial bodies, purported Jupiter-mass binary objects, or in short, jumbos. The way that this discovery was met with shock, to say the least, among scientists is primarily because the jumbos fulfill their name absurdum. The reason is that it really looks as if these recluse planets in the Orion Cloud happen 2 by 2. So what is the background to these surprising star groupings? Luckily, scientists were able to uncover some basic characteristics of the jumbos following the Webb pictures. These are galactic whippersnappers, just 1 million years old, and have surface temperatures of around 1,000 degrees Celsius. But how did the jumbos end up in such large numbers and in pairs in the Orion Cloud? Why are the jumbos so strange? Well, we can hypothesize about that for now, and the same applies to the subject of what these large objects really are. The primary theory is based on the assumption that the jumbos were born in a region of the Orion Cloud that was too poor to matter in the formation of real stars, since there wasn't enough hydrogen available here for the formation of stars and the initiation of nuclear fusion. We could thus be dealing with a segment of failed stars. On the other hand, however, There is also the hypothesis that the jumbos initially grew in the normal manner to become Jupiter-like gas giants, but were eventually literally ejected from their home system by an unknown event. And although the scientists stress that they believe the ejection hypothesis to be the more likely one, they also admit that they don't know why the celestial bodies were separated from their mother stars two by two. Clear explanation sounds different though. Given the structure of the giants, is it at all possible that we are dealing with the result of an irregular event? After all, the fact that the celestial bodies always come two by two is accompanied by the reality that they all have the same design and mass. Considering this, some researchers point out that we should perhaps concede that our models for planet formation and development are likely far from complete. At the end of the day, the structure in the Orion cloud could be based on a key system that is completely unknown to us. Who knows? Perhaps the corresponding structure represents not just a constant star maker, but also a fully fledged, massive factory. If the hydrogen density here is always distributed in specific areas in such a way that it can never form a real star, but consistently creates two gas planet-like objects that are gravitationally bound to one another, we would no longer talk about an accident but rather a system. And although this approach may seem plausible, it's still pending official confirmation. What has now been officially confirmed, however, is the finding that the James Webb Telescope has identified a whole series of objects that have left specialists scratching their heads. How Webb is pushing cosmology to its limits. As mentioned at the start, these include, above all, the inconceivable galaxies that already existed 500 to 700 million years after the Big Bang and which, despite this, contained up to 100 billion solar masses of stars. The reason why these structures became known as universe breakers is that they are in sharp contradiction to current cosmology. According to our hypotheses, there simply wasn't enough normal matter at such an early stage to form so many stars in such a short time. And just like with the jumbos, the question arises as to how complete our theoretical understanding of cosmic evolution is, and how much it actually matches the real processes in the universe. No less confounding is the massive black hole that the James Webb Telescope identified in a similarly early galaxy. This was already present 770 million years after the Big Bang, and yet a gravitational beast of more than a billion solar masses slept at its center. Scientists investigated which feeding mechanism allowed the black hole to grow to such sizes so early on, but they found nothing particularly new. Instead, the object's formation appears to be surprisingly normal. So, the cosmic mystery ultimately grew as such. The very massive black hole was already fully mature when the universe was only 5% of its current age, and we have no clear explanation for this perplexing growth pattern. And then there is also the issue of the so-called Hubble strain. In principle, the Hubble constant shows the rate at which the universe is currently expanding, but oddly enough, past studies had already uncovered an incomprehensible inconsistency. While the determination of the Hubble constant based on the cosmic background radiation is theoretically 67 kilometers per second per megaparsec, the actual measured values turned out to be significantly higher. If we take red giants, supernovae, or the special type of star called Cepheids into account, we suddenly get a value of 73 kilometers per second per megaparsec. So, was this an experimental error in the past? Tragically, no. Because the observations of the James Webb Telescope have confirmed the Hubble strain. According to the experts, the faster expansion of the universe could be caused by a process or force that has not yet been accounted for in the cosmological standard model. For example, an interesting type of dark energy or dark matter, but it's also possible that we have misjudged the real properties of gravity or that there are particles or fields out there that no analyst has yet known about. And now comes a strong call to subscribe, something you should have heard. We invite you to press the like and subscribe buttons to never miss another video from us. We'll see you soon.